The oscilloscope is used to show electrical signals as voltages over a known period. This is shown as a waveform or a plot of the voltage over time. The observed waveform can be analyzed to learn useful information about the signal. Using the probes, a real-time graph of the voltage can be made for any point on a circuit. This tutorial will introduce you to some of the basics of using an oscilloscope. If you are wondering about a specific topic, check out these links. One great way to make sure your probes are working is to connect them to the oscilloscope's built-in test signal. This is done by pulling back on the probe's protective shroud, called a witch hat, to expose the hook. Connect the alligator clip to the ground reference, and the hook to the test signal. This isn't something that you need to do every time, but can be a useful debug step in order to ensure your probes are not damaged. It is impossible to take measurements of a waveform with the readings scrolling all over the display. For this section, we have the oscilloscope hooked up to the function generator producing a 75 Hz sine wave. The connection is simple. Ground the alligator clip to the ground of the function generator and attach the probe to the output of the function generator. The trigger system lets you specify a point in the signal to be captured at the same place every time. Watch as the sine wave intersects the trigger level at the trigger point, indicated by the orange T in the top center of the screen. To change the trigger level, twist the knob in the trigger section of the control panel. If you are having difficulty getting the signal to trigger, pressing down on the trigger level knob will set the trigger level to 50% of the waveform amplitude. To change the trigger settings, press the menu button in the trigger section. The most common triggering method you will use is edge triggering. With edge triggering, the waveform is anchored to a specific point in time when the waveform passes through a specific level, while either rising or falling. Using the settings in this menu, you can set the trigger to activate on the rising or falling edge. Now let's try manually adjusting the scale to see if we can get a better looking waveform. For this test, we are using a 120 Hz square wave from the function generator. First, you can try to use the auto set button to automatically scale the waveform. This will not always be the best scaling, but it is often a great place to start. You can see on the screen that the display is divided into vertical and horizontal dotted lines that partition the vertical and horizontal scales. The vertical scale and position can be adjusted using these knobs, and the horizontal position and scale can be adjusted using these knobs. Using these knobs together, we can get a better fit for the data. The horizontal scale knob adjusts how much time each block on the screen takes. The horizontal position knob shifts the waveform left and right in the time axis. The X offset is displayed at the bottom center of the screen. Note how the orange trigger point moves with the waveform. The vertical scale knob changes how many volts each block represents, and the vertical position knob shifts the waveform up and down. The Y offset is displayed in the top left corner. Each of these knobs, with the exception of the horizontal scale knob, also function as a button. Pressing the position knob centers the waveform, and pushing the vertical scale knob is a shortcut to selecting that channel as the trigger channel. Notice how the signal is no longer triggered, as channel 2 is our triggered channel. You can turn on and off the individual channels by pressing the 1 and 2 buttons respectively. This also brings up the channel menu. In the channel menu, you can change the attenuation factor. On many other oscilloscopes, this will appear as a switch on the probe itself. To achieve higher accuracy, increased impedance is required. For our purposes, times 10 is fine. If you want to learn more about how and why probes are attenuated, check out the SparkFun Oscilloscope Guide linked in the description. Lastly, you can use the zoom button to get a preview of an adjusted horizontal scale. Using the multi-purpose knob, you can zoom in and out, and by pressing the knob or the contextual buttons, you can switch to scrolling through the waveform. Now we will discuss the various ways to measure your waveform. For this test, we will be using a 75 Hz square wave. Press the measure button in the navigation section. Here, we can use the multi-purpose knob to select measurements. Twist the knob to scroll around and press it in to select the highlighted option. You will see a description of the measurement in the bottom of the screen. For now, I will select the frequency, amplitude, and positive duty cycle. You can clear all selections by pressing the contextual button in the bottom right of the screen. Now, press the menu on-off button to return to the waveform. You can see how the measurements selected are overlaid on the bottom left of the screen. We can press the menu on-off button again to minimize them. Additionally, we can use the cursor to make manual measurements. You can pause the waveform to make manual measurements easier by pressing the Run Stop button in the upper right corner. By twisting the multi-purpose knob, you can move cursor 1 around. By pressing the multi-purpose knob, you can switch which cursor you are controlling. Pressing the Find button will give you more finite control of the cursor's location. You can swap the cursor to the Y-axis by pressing the contextual buttons labeled Amplitude and both X and Y by pressing the contextual button labeled Screen. While manual measurements can be useful, it is recommended you use the Measure menu for most of your measurements, as these have precise edge triggering. Let us now configure the probe to measure waveforms at 2 different points in a circuit. Here we have a simple RC circuit. We will connect the first probe to V-in and the second probe to V-out. This way we can compare the input and output of the RC circuit. After connecting the second probe, you should see something like this on the oscilloscope display. With that done, we can now take a picture for use in our lab report. Lastly, we will cover capturing data. Make any final adjustments to the position and scaling. Although you do not have to, it can be useful to pause the display by pressing the Run/Stop button in the upper right corner. This way you know exactly what will be captured. It can also be useful to press the Menu On/Off button in the lower right corner next to the screen to cycle the menus that are being displayed. Now simply put a thumb drive in the USB port and press the Save icon in the upper right corner next to the screen.